Hello everyone, how are you doing? Personally, I'm doing good. Thank you very much for tuning out today's lesson till the end. Kindly listen and please subscribe. Let us look at these questions together. As you can see, we have a question here on indices, another one on logarithms, and this is covered in grade 9 at Genesis level. As you can see, we have 27 power 2 over 3, whereby we call these fractional indices. And in fractional indices, we take the denominator and first handle the denominator first. That is 27 power 1 over 3. We first hold the 2 and assume that we have 1 over 3, whereby we talked about these in cube roots, whereby we are supposed to first get the cube root of 27 in this case, and this is a cube root of 27, which is equal to 3. Cube root means that we find a number that when multiplied by itself 3 times will get the number in question. That is, in this case, it is 3. Then from there, we can now go back to the 2 that we had held, and we'll have 3 now, power 2. And 3 power 2 is the same as 3 times 3. We square the number, we multiply the number by itself 2 times, and this will give us 9. Yes. Then now from there, we can move to logarithms, whereby we are supposed to write this number in index form, which is already in logarithmic notation. And in this case, we'll have this number is written as log 1000 base 10 is equal to 3. Now in this case, when we want to write the number in index form, we maintain the base 10, then we say the power is always the logarithm of a number. Therefore, the logarithm of this number to base 10 is 3, meaning that 3 is the power. So we have 10 power 3, and this will be equal to 1000. And you can prove that 10 power 3 is 1000, because 10 power 3 is the same as 10 times 10 times 10, which is 1000. Yes. Let us look at this question together, and as you can see, the question is from compound ratios, grade 9, and as you can see, we are given if A is to B is equal to 4 is to 7, find the ratio 4A plus 7B is to 5A minus B. So in this case, it means that if A is to B is equal to 7 is to 4 is to 7, it means that A, let us have solution. It means that A is equal to 4 and B is equal to 7, meaning that we can substitute the values of A and B in the ratio in the question. So we'll have 4 is to A, which is 4, then plus 7 is to B, which is 7, and this is to, sorry for my space, but so you handle it there, this is to 5 into A, which is 4, and then minus B, which is 7. And then we can simplify this. We'll have 4 times 4, which is 16, plus 7 times 7, which is 49. So we'll have 16 plus 49 is to 5 times 4, which is 20, minus 7. And then we'll have 16 plus 49, which is 60, what? 65. So 65 can see, we are looking at order of matrices, and you're supposed to find the order of the matrices below. As you can see, we have this matrix with elements 2, 5, 3, whereby we are going to find the order of the matrix. And in order of matrices, we say that we take the number of rows, we multiply by the number of columns, and we are strictly at the order. The order. You must strictly start with the rows, then by columns. This is not multiplication, it's by. We read it as by. And then let us look at how many rows does this matrix have. As you can see, rows are the numbers in vertical order. We have rows, then we have columns. So we only have one row, and then we have 1, 2, 3, 3 columns. So we'll have 1 by 3, and that is the order of that matrix. 1 by 3, 1 by 3. It's the order of the matrix. We move to the next matrix here, whereby we'll have the number of rows and then the number of by the number of columns, and we'll have how many rows are here. I said rows are the vertical arrangement. So we have 1, 2, 3. So we have 3 rows by how many columns? The horizontal arrangement 1. So by 1. Look at that. So anytime you call a 1 by 3 matrix, you see that it is a 3 by 1 matrix, you mean something else. So you be very careful on the order. That is rows by columns, not columns by rows. Yeah, I've seen that learners have a confusion in that, which is just a simple thing, which needs to be understood clearly. So the last one here, as you can see, we have these elements in that order. And then we can identify the number of rows here, then by the number of columns. How many rows do we have? Said rows are the vertical, the rows are the horizontal arrangement, then columns are the vertical arrangement. So this will be, we'll have 1, 2, 3 rows by 1, 2, 3 columns. So this is a 3 by 3 matrix. Matrix of order 3 by 3. Let's look at this addition of matrices together. As you can see, we have a matrix here being added to another one, and we can do these together. So in matrices, we add the elements in the same position, because remember we also have position of elements in a matrix, whereby we have the first element here, which is 3, is in the first row, first column. So the number in the first row, first column is added to the other number in the first row, first column of the other matrix. The second one is 1, which is in the first row, second column, will be added to 5, which is in the first row, second column, and so on and so on. So let us do that. This will be the same as 3 plus 4, 3 plus 4. The other one is 1 plus 5, so 1 plus 5. The other one is 4 plus 0, so 4 plus 0. We'll have 7 plus 2, 7 plus 2. We also have 2 plus 9, 2 plus 9. You can have these in brackets or just avoid, no problem. same as 3 plus 4, which is 7, 1 plus 5, which is 6, 4 plus 0, which is 4, 7 plus 2, which is 9, 2 plus 9, which is 11, 5 plus 7, which is 12, 0 plus 1, which is 1, 6 plus 8, which is 14, then 8 plus 3, which is 11. That is the matrix. We enclose it, and again, you also make sure that the elements are spaced. This is 14, should clearly be seen that an element, not 1 and 4.